Next, we're going to talk about molecular formula, okay, and how we can figure that out. So remember, our molecular formula is our actual number, right? We just finished talking about empirical, which is our simplest version, right? So again, here's some more examples, right? Our actual amount of carbons is 10, 22 hydrogens, but our empirical, our reduced, simplified formula is C5H11. Okay, so let's look at this example here, all right? And you can just kind of follow along. So it tells me, right, that I have a formula. This is its empirical formula, right? That's CF2, okay? The actual formula that I'm looking for has a mass of 200.04 grams, right? So if I'm like kind of think about it, right? I know that carbon and fluorine let me find fluorine's mass on the periodic table. So something like this, something like that. It might be written as 19 actually on yours now that I think about it. So we'll just use 19 just to make it easier on ourselves. Okay, so if I wanted to find the mass of this formula right here, right? I have one carbon, so that's 12, and I have 2 fluorines. So if I add all of that up together, I get 50.01. Okay, so the mass of this empirical formula is 50.01. So what I'm trying to do is find another formula that can simplify down to this, right? But has a mass of 200. So let's say that we double the elements in this formula. So instead of just 1 carbon, we have 2. And then we have 4 fluorines, right? So now we need to add up our mass of this. So if I have 2 carbons, that means I'm going to have 12 plus 12. And then I'm going to have to add 4 fluorines. Right? So I get 100.02 grams. Right? So because I doubled the amount of elements that I had in there, right? Really, all I did to get to here was just double my mass. Right? So let's keep going. I'm not quite at 200 yet. I'm only at 100. So let's say we just add, right, 1 more of our empirical formulas. So we're going to take this and multiply by 3. So now instead of 1 carbon, I have 3 carbons, and I have 6 fluorines. So if I add everything up, find my mass for this compound, I get 150.03. Still not quite at 200. So let's go one more time. Let's see if I take that empirical formula and I multiply it by 4. Okay, and then I add up the mass. I end up with 200.04 grams. Okay, so this right here is my molecular formula because it has the empirical formula, right, that I'm looking for, and it has the correct molar mass, right? So this is essentially the thought process, right, that we're doing. We're saying, okay, how many times do I need to multiply my empirical formula to get the correct mass, right? There's a much shorter way that we can do that. So let's look at that now, okay? So let's see. Yeah, we'll just do it this way. So I have C2H20. That is my empirical formula, right? So if I want to find the mass for my empirical formula, I'm going to add up my carbons. I also have 2 hydrogens, and then I have 1 oxygen. So I'm going to add up all of those masses. And I get 42.04. Okay, so the empirical mass is 42.04, right? So on your notes, you have this little formula. I'll just kind of scroll down right here. Okay, so we have this little, I guess, telling you what to divide by, right? So we can take, just like in the previous example, we had to write everything out, and we finally figured out that we needed to multiply everything by 4 in order to get that 200. Okay, so, and then we said there's a faster way to do it. So the faster way is we can actually take the mass of our molecular. Okay, so for this example, we're told that the mass of the molecular is 126. Okay, so we're going to take 126.12 grams per mole, and then we can actually divide by that empirical mass. So that would be this 42.04. So we're just dividing the mass. We're saying how many of these empiricals that weigh 42 grams can fit into the real deal, the molecular formula. So if we divide, I end up with 3. Okay, so what that means is I'm just going to take my empirical formula and I'm going to multiply it by 3. So I end up with 6 carbons, 6 hydrogens, and 3 oxygens. So this is my molecular formula. All right, so we have one more practice, okay? I'm going to walk you through very quick the empirical formula section, and I'm going to let you try the molecular formula. Okay, so remember, for our empirical formula, we're just going to start by writing down what we're given, writing our percents. If you want to pause here and try it yourself, that's fine, but you do not have to. Okay, so remember my first step, percent to mass. So I'm going to change all of my percents to grams. Percent to mass, mass to mole. It's going to be kind of small writing, but I'm just using my molar masses, right, to go to moles. So I went percent to mass, mass to mole. So now I'm just going to divide. And again, I'm just using about 2 decimal places is fine for these problems, most of the problems that we do. Okay, so percent to mass, mass to mole, divide by small. So what is my smallest number here? It says 1.23. So I'm going to divide all of these by 1.23. I get 5.000, so this is essentially 5, right? Our whole number. 8.61. This one comes out to exactly 7. And then we know that 1.23 divided by 1.23 is just 1. So my empirical formula, I have 5 carbons, 7 hydrogens, and just 1 nitrogen. Okay, so that's my empirical. So remember, when we find our molecular formula, we just want to take our 2 masses and divide, right? So we always have the mass of our molecular divided by the mass of the empirical. One way that you can kind of try to remember that is that you just think me. So M-E, me. Okay, so you know that M has to go on the top, okay, the molecular mass. So let's look at our problem. It tells us that it has a molecular mass of 162. So I'm just going to plug that in, 162.1. And now I need to find my empirical mass. So remember, how are we going to do that? Well, this is my empirical formula, so I just need to add up all my carbons, right? I have 5 of them. I have 7 hydrogens, and then I just have 1 nitrogen. So we're going to add up all of those values. And I got 81.13. So again, me, empirical goes on the bottom. So now I can just divide. And this comes out to be like 1.998, which is basically 2, right? We're just looking for that whole number ratio. So now all I have to do is come back to my empirical formula. I just know I have to multiply it by 2. So this is my molecular formula. So that's all for the notes. Feel free to go back and look at any practice problems if you need to. Your next step is to go through and complete parts 4 and 5 of the case, and that will get you a lot more practice. And then as always, if you have any questions, feel free to